All right, so in this video's lesson, we're going to be taking a look at this third operation. So we've already seen addition and subtraction. We're now going to look at multiplication and see how that works for complex numbers. Now, as we're multiplying, it's going to be important to remember to use the distributive property and also this fact that I squared is equal to -1. So if we ever see I squared, we're going to simplify that to rewrite it as -1. So let's take a look at an example. In this first one, we have a very basic complex number of 2i multiplied by -4 minus 3i. So we'll go ahead and start by distributing 2i multiplied by -4 is -8i. 2i multiplied by -3i is a -6i squared. So just like when you're multiplying variables, make sure that when you're multiplying I together for two different terms, that becomes I squared. All right, so then simplifying, remember I squared is the same as -1, so I'm going to replace that with a -1. And then we'll go ahead and simplify further, -8, and then -6 multiplied by -1 is a +6. Now, that's as far as we can go simplifying. However, it's convention to write -6 minus 8i. So make sure that you're putting it in what's called standard form. So standard form is that you use the real part first and then the imaginary or complex part second. All right. For this next example, we've got a little bit more distributing to do, but the same ideas are still going to hold. So we'll start by distributing the 3. So 3 multiplied by 5 is 15. And then 3 multiplied by -4i is -12i. Then we'll go ahead and distribute the 2i. So 2i multiplied by 5 is 10i. And 2i multiplied by -4 is -8i squared. All right, so a couple of things we can do. First is that we can combine our like terms in the middle of that expression. So -12i plus 10i is a -2i. The next thing we can do is we can rewrite I squared as -1. So then we can multiply those together, 15 minus 2i plus 8. And then once again, combine like terms, 15 plus 8 is 23. And then we'll put the -2i after. All right. Now for example C, we need to be careful. Just like we wouldn't do it if it was x minus 3, we aren't going to just take 2 to the power of 2 and -3i to the power of 2. That's probably the most common mistake that we'll see made when we look at the homework as well as the quizzes and tests. Instead, the best way to work this would be to rewrite it as 2 minus 3i multiplied by itself. That way we'll remember to distribute. So 2 multiplied by 2 is 4. 2 multiplied by -3 is -6i. And then -3i multiplied by 2 is -6i. And -3i multiplied by itself is going to be 9i squared. So now let's go ahead and simplify and combine our like terms in the middle. -6 and -6 is -12i. And then I squared we will replace with -1. All right, so let's go ahead and multiply those together. 9 multiplied by -1 is a -9. So really, if you think about it, and what we'll start to do in order to make simplifying easier is that I squared just changes the sign of the number that's in front of it. So if it's a +9, then it becomes a -9. All right, but to go ahead and finish this one out, let's go ahead and combine our like terms. 4 minus 9 is -5. We'll copy the -12i after it. And there would be our final answer for C. All right. Let's next take a look at D. So on example D, let's go ahead and start by distributing. So we'll get 3 multiplied by 3 is 9. 3 multiplied by -i is a -3i. Then we'll take I and multiply by 3 is 3i. Then I multiplied by -i is a -i squared, or a -1i squared would be another way to think about that. All right, so as we're simplifying, -3i and 3i is actually going to add to be 0. So we can go ahead and just get rid of those. And then remember, I squared changes the sign of the number that's in front of it. So if it's a -1, that will change it to be a +1. And then to simplify, 9 plus 1 is 10. And actually, that's our final answer. So in this case, we actually multiplied two complex numbers and just got a real number out of it. It's actually a special thing that we're going to talk about actually in just a moment, this idea of what's called a complex conjugate. Now, you can also still think about this as being a complex number. You would just think of it as being 10 plus 0i. So really, either one of these is okay. I just mentioned that to show you that it really is still a complex number. In fact, if you think about it, all real numbers are complex numbers. And so the complex number system is actually larger than the real number system, which is kind of weird to think about. All right, let's go ahead and take a look at example E next. So on example E, we'll go ahead and distribute 4 multiplied by 3 is 12. And then 4 multiplied by negative I is minus 4i. I multiplied by 3 is 3i. And I multiplied by negative I is a negative 1i squared. All right, so simplifying, negative 4 plus 3 is negative 1i. And then remember, I squared changes the sign of the number in front of it. So negative 1 becomes positive 1. So then we just combine our like terms. 12 plus 1 is 13. And so we get 13 minus I. All right, last example before we talk about our second concept for this video. So in this example, very much like A, we're just distributing 12i to both of those terms. So the first is multiplied by 3, which gives us 36i. The next is just going to give us 12i squared. Which then remember, I squared changes the sign of the number in front of it. So that's going to become 36i minus 12. And then don't forget to put it in standard form. So the negative 12 should go first, and the 36i should come second. And there would be your final answer. All right, so the rest of this section is really going to focus on what we saw in example D, where when we took 3 plus I and 3 minus I, we multiplied those together and just got a real number. We got the number 10. And actually what we did, and you probably didn't know it yet, is that we were actually multiplying what are called complex conjugates. So a complex conjugate is a complex number with a sign change between the two terms. In other words, the complex conjugate of A plus BI is A minus BI. So let's just do some practice with finding the conjugate for some complex numbers. So on example A, you've got 6 plus I as your complex number. The conjugate then would be to change the middle sign to be a subtraction, so 6 minus I. Notice that when you change the sign, you only change the sign in the middle. So we're not putting a negative in front of the 6. We're only changing the plus in between to being a minus sign instead. All right, for example B, that's going to be important because notice that it's subtraction. So we're just going to change it to addition, negative 2 plus I. All right, for this next one, it is a little bit tricky just because it does not have a real part to it. So if you wanted to think about it as 0 minus 13i, that would probably be helpful in finding the conjugate. Because the conjugate, you would just change the sign to being 0 plus 13i. But in writing the conjugate, obviously you don't need to put the 0 there. You can just write that 13i is your conjugate. All right, finally, for example D, again, a special case where you don't have the imaginary part. So negative 7 plus 0i becomes a conjugate of negative 7 minus 0i. Again, the minus 0i you don't need to write. So it turns out that the conjugate is just that same number, which is negative 7. All right, so to finish off these notes, let's see what happens when we multiply these conjugates together. So we're going to start by multiplying the pair from example A, which was 6 plus I and 6 minus I. All right, so as we distribute that, we'll get 36 minus 6i plus 6i minus I squared, or minus a 1i squared. Now again, notice that negative 6i and plus 6i are going to add to be 0. The the I squared is going to change the -1 that's in front of it to a +1, and we just get 37. For example B, we had -2 minus I and -2 plus I. So let's go ahead and multiply those together next. All right, so multiplying, we're going to end up with 4 minus 2I plus 2I minus 1I squared. Again, notice that -2I and plus 2I are going to add to be 0. And then the I squared is going to change your -1 to being a +1. And then 4 plus 1 is 5. So again, we ended up with a real number. And you might already see kind of where this is headed. For the next one, we had -13I and 13I. Let's go ahead and multiply those together. So -13 multiplied by 13 is -169. If you take I and multiply by itself is I squared. Remember, I squared just changes the sign of the number in front of it. So instead of a -169, you get a +169. The last is probably the easiest. You had -7 multiplied by itself. -7 multiplied by -7 is 49. So what do we notice about multiplying by the conjugate? Well, we get all positive numbers, sure. We also have I squared changes the sign, but if you notice, every single answer is just a real number. So when you multiply by a conjugate, so multiplying two conjugates is always going to be just a real number. That's going to be super important in our next lesson where we're going to talk about dividing complex numbers. Because dividing complex numbers is where you're trying to get rid of the complex in your denominator. And so to do that, now we have something we can use, this idea of multiplying by what is called a conjugate. All right, that's it for this video lesson. Until next time, have a great rest of your day.